At this time, I'd like to introduce our presenter, Andy Kester, Director of Product Marketing for Aspiration and Specialty Detection for System Sensor. Andy, take it away.
All right, thank you much, David. Can everyone hear me okay?
We can hear you fine, Andy. Thanks.
Okay, great, David. We had a little audio issue before we started, so I just wanted to verify. Again, to David's point, today we're really going to focus on one aspect of FAAST, and that's the PipeIQ, or the integrated software for FAAST. So basically our discussion topics for today will be, we'll give a very slight brief overview of aspiration in general, and then also the FAAST product that we launched back in the third to fourth quarter of last year. But again, the core focus today will be on PipeIQ. And then finally, we'll wrap things up with some additional educational opportunities that are available today or coming soon. So what exactly is aspiration? Those of you that have joined us for the last several series of webinars that we've done on aspiration and FAAST, this will be a little recap for those of you that haven't. Hopefully it'll entice you to go back and review those webinars. We do have those previous webinars archived on our website that we'll talk about a little bit later. So what is aspiration? Aspiration typically is a fan which draws air through sampling ports through a pipe network. That air passes through the system, in through a filter, and into a sensor for the purpose of detecting smoke. Typically or historically, those systems are used with infrared lasers based detection sources, which have their limitations, have their good points, but also limitations when it comes to false alarm immunity. So what does FAAST offer from an advantage standpoint? Again, this is just a real recap, a summary. It really is a product with superior technology. Not only do we have our dual vision detection, so we have a blue LED detecting dust. We use an infrared laser to detect nuisance-based conditions such as dust. Also has patented multi-stage filtering process, which further supports the false alarm immunity of the product. Something that really sets FAAST apart is we have TCP/IP integrated Ethernet communication. We'll talk about that as we're talking through the PipeIQ software and what some of the advantages of that. One of the big advantages are that the device can send email updates of status notifications. The core focus of the balance of this presentation will be on the PipeIQ software. It's comprehensive, all-in-one software, very easy to use. Intuitive interface, you can see on the image here, there is a display that makes it very, very easy, whether you're at the device or remote to monitor the device. Also makes it, we try to make FAAST very user interactive from a standpoint of the system automatically calibrates not only an Acclimate or the sensitivity range of the product, but also the fan requires no calibration whatsoever. So with that, we'll turn it over to David for the first poll question.
All right, Andy, thank you. So we do have a couple of poll questions we're going to ask you. So if you would answer on behalf of you or your business. The first one is hopefully an easy one. What best describes your company's focus or role? So what do you do for a living here? Are you a systems integrator? Maybe you're an ESD. Are you an engineer working within an A&E firm, perhaps? A contractor, an installer, a technician. Maybe you're on the what we would call the end user side. You're a building owner, facility manager, maybe you're a site leader, or you're other. If you could just take a moment and just let us know who's on the line with us, that sometimes helps us gauge the presentations or even future presentations, and we would appreciate that. So I see about 70% of you have voted. I'm going to wait a few more seconds. If you haven't voted yet, we do appreciate it, and we do have a large audience on with us today, so we do appreciate you being here and finding out about this new product and new information. All right, we're over about 85%, Andy, so I'm going to go ahead and close that poll. And I do promise to share these poll results with you every time. So, Andy, it looks like about 38% fall in that integrator or ESD role. Boy, you guys are in the right place. And about 24% other, so that's probably made up from some of our own people and some of other industry types. And the next largest category is contractor, installer, technician. So thank you for voting. There'll be two other opportunities here to vote. So Andy, let me put those poll results down, and back to you.
Okay, great. Great to hear that there's that many ESDs on the phone. We kind of classify your demographic as the parts and the smarts, so hopefully today you'll be able to expand your knowledge on both. So with PipeIQ, basically PipeIQ is the comprehensive software that enables not only pipe design and layout, system configuration, and a lot of that centers around the device, but also some changes that you can make within your system. And then also, it also supports device monitoring, and that there's 3 or 4 arms to that device monitoring, both at the device and some other options remotely. It should also be noted that PipeIQ does ship as a CD with each FAAST device, and it's also available for free through our systemsensor.com/FAAST landing page or website. Again, implore you to go ahead and do so if you haven't done so. Again, because you can get it off the website, you don't have to buy a product first before you get familiarized with the software. So the first thing we're going to talk about is pipe design. So once you open up the software, you do get kind of a traditional Microsoft look, if you will. So if you select View and come down to Pipe Design, you select Pipe Design, and it does open up the initial pipe layout or design screen. The pipe layout design really offers 2 different ways to lay out your system and design the piping for the aspiration product. The first of which is a pipe wizard, and that really is, if you think about the same way you maybe install a piece of software or a new printer or something like that, where it gives you screen by screen, step by step radio buttons, dialog buttons in which it's kind of multiple choice, fill in the blank kind of things, allows you to do so, gives you that step by step design guidelines. It's really ideal for any kind of standard rectangular spaces with little customization. It also can be used as a starting point where you can use the wizard to design a standard layout, and then you can go ahead and manually edit that design as well. Again, great for first-time designers, just kind of getting your feet wet. In addition, the software also supports manual design, and this is where you're actually laying out the system pipe by pipe, fitting by fitting, if you will. It does also have the ability to import a simple DXF CAD file. So you have a certain design you already have, gives the layout of the room. You can import that into the software and then design your pipe network around that. Again, much more ideal for the highly custom designs and networks. So a little more summary on the Pipe Wizard. Again, gives you that step-by-step. I'm not going to spend too much time on this because we are going to go through a simulated setup, but can select things anywhere from the type of detection that you want, whether it's standard detection, early warning, or very early warning, all the way through whether or not you want the device located inside or outside the room. So with that, we'll go ahead and run through a little sample of Pipe Wizard. So we're in the software right now. We go ahead and select the Pipe Wizard, which my cursor is moving around a little bit, but it'll make that connection. So as you can see, you're able to select very early warning, or non-early warning. And what that does is it allows you, it actually sets not only the square foot coverage, but also the required transport time in association with NFPA 75 or 76. So we'll go to the next screen, and this is the room screen. So this is where we set up the actual size of the room. Again, it's based on a pretty much standard rectangular square room. So we're going to select a room that's 60 by 30 with a height of about 12 feet. And you'll notice that the system automatically noticed it couldn't do it with a single pipe network, and it had to select a simple branch or an H branch, and you have the choices between those two. Now I'm going to move ahead to the next screen. This is the actual pipe network. So this is where you're allowed to decide whether or not the pipe system or layout is going to be above the ceiling, below the ceiling, or also below the floor. So if you're thinking about a computer room, you might have a pipe network below the floor. And the FAAST unit's great because it's able to actually have manifolds that can connect the pipe from the top of the device or the bottom of the device. So if you're doing a subfloor setup, there's already a manifold there for pipe connections at the bottom. So we go ahead on to the next screen or selection window, and this is where we actually select the pipe. Now, the type of pipe really doesn't come into play for the calculations, but what it does do is when you do go to the output reports, where you can actually output reports of bill of material on that, it will list the proper pipe material as selected on this screen. Okay, so then we move on to the next screen, which is really the detector or the location of the detector. You can select whether it's going to be inside the room or outside the room. If you're selecting it outside the room, there is a warning or a note that advises that you really need to exhaust the device back into the same space in which you're sampling, just for pressure differential standpoints. Okay, and you can also select how high it is off the floor, whether it's inside or outside the room. Okay, and then, so once we've made all of our selections, you go to the next screen, and it basically summarizes all your details, gives you an opportunity to verify that you're doing that. Once you've made that selection, you click Finish, and it'll bring up the actual pipe network. Okay, so now we have a pipe drawn. We can go ahead and zoom extents, take a look exactly what that pipe network looks like. There's different views that you can take of it, so whether it's an isometric view, a front view, a top view, or a right view. There's also a pan feature that allows you to move the layout around so you can take a look. You'll also note that we have sampling drops that show up. So that, remember, I selected above the ceiling. So at each one of the sampling points, you see a little vertical line coming down. That would be where capillary type tubes would come in and connect to a drop ceiling. So again, it has all that type of features. So once we kind of take a look at the design, we can actually look at the calculation results. So go to the next screen, and we'll click on the little Calculate button. And that brings up, again, the calculated results. The main areas that we're looking at here are the fourth or fifth column, which is the transport time and hole sensitivity. Again, based on NFPA and based on local authority, you typically have to maintain a certain transport time. Quite often for early warning or very early warning, it would either be 90 or 60 seconds. You can see here outside of 60 seconds, but inside of 90. So it works very well for early warning. What you can also do is if something's outside of your limit, you can adjust your hole sizes in order to generate more airflow through those ports and actually drive down your transport time. So here again is another snapshot, again just highlighting the transport time and the hole sensitivity. There's a host of information that shows up on this report. Those are typically two of the columns that you're going to pay most attention to. Okay, so now we've gone through the Pipe Wizard and done a very simple example of that. Now we're going to go through an example of actually manually laying out a system. And the highlighted icons that are here are really for the detector and the pipe, as well as where you would import a DXF file. So with that, again, we're in the drawing mode. We'll go ahead and select it. We're going to place a detector, so we click on the detector icon. Again, using the zoom features, we can zoom that up and take a look at the device, get a little better look at it, perhaps change the view from a top view to a front view. And we'll start adding pipe to the network. So the first pipe we're going to add will be a short pipe. Think about vertically trying to get up near the ceiling height. You can place a pipe without holes if it's not a sampling pipe. So we click pipe without holes. We'll zoom out a little bit to be able to take a look at that and see where we want to place that pipe. Basically just clicking and dragging the pipe over to the connection point of the device. You'll notice that when a pipe was originally placed, it was red. Once it's connected to the system, it actually turns green. So we'll go ahead and continue to build that pipe network. So we zoom it out a little bit, see where we want to make that connection. So now we're going to add a horizontal pipe to the network. Again, this is still getting to the space, so we're going to end up putting in a 4-foot pipe. Again, pipe without holes. It is important to note that you do need to select whether you want the pipe to start from the left to right or right to left. You can see there, once it was connected, it did change from red to green again. This pipe, again, will make 4 feet. We're going to go the other direction, so we go right to left. And again, it's a pipe without holes. So we click it and drag it over, and again, once it's connected, it turns green. So now we're going to go ahead and add in our sampling pipes, if you will. So now we've gotten up to the ceiling. We've made the spread with the branch that we want. And we're going to start putting in the view that we're at, it would be some vertical, or I'm sorry, vertical pipes. Again, because we're in a top view. So it's actually in our space, it'll be a horizontal pipe. So now we calculate and place holes. So based on the space, it's a fairly small space, only requires one hole in that particular network. Don't be afraid if you don't see the pipe initially. Zoom Extents will find that pipe for you. You can grab it and drag it into your space. Okay? So that was one branch. We'll go ahead and add the second branch. And let's just say that this is an odd-shaped space, so instead of both lengths being 20 feet, one will be 20 and one is 30. So we have some sort of oblong-sized room that we want to make sure we have proper connection to. Again, pipe shows up. Go ahead and drag it across and make the connection at the point that we want to. Okay, we can take a look at a nice metric view of that. If we go ahead and zoom out a little bit, we go ahead and do a calculation. And you'll notice it said verify the pipe design for disconnected entities or end caps. So basically I tried to check the calculation, but because these are sampling pipes, you need to add end caps. I didn't do that when I placed those pipes, so we'll go ahead and do that at this point. So it's fairly easy. You do need to be in a top view to check those. So you double click on the pipe. It brings up that pipe layout. You click add end cap. Click OK. It goes ahead and puts that one in. We'll go ahead and click the other sampling branch, add end cap. And again, click OK. Go back to an isometric view. And then we'll go ahead and check the calculation. So again, we click on the calculator. And again, it brings up that same calculator result. So whether we're using Pipe Wizard or the manual design, you can see you get the same type of features. You can see this particular layout, I'm inside of 40 or 50 seconds, so it could qualify for very early warning. Okay, so once you get done with all the designs, not only do you have that calculator report, but there's additional reports that can be exported into a PDF form, and those are highlighted here over on the right where it says reports. There's both a bill of material report and a pipe layout report. So here you can see an example of these reports. Not only on the left do you get a summary of what the inputs were, you also get pipe by pipe layout of what segments you are required. Excuse me, joints and fittings as well. And then you can go to a layout report, which again, it gives you some summary of how much total pipe length is required, the maximum transport time that the system requires from the furthest point, hole sensitivity, as well as a brief schematic that, again, can be exported back out of the software in a PDF form. Okay, David, we're ready for the next poll question.
All right, Andy, very good. The next poll question talks about your company's design capabilities. So we're looking at your in-house design capabilities. So what best describes your company's design staff capabilities? So those personnel that work with you directly. Do you have complete or extensive certified designs in-house? Do you complete them for your projects? In-house, do you use in-house design resources whenever possible, maybe for easier projects or lighter projects, but maybe for heavier things you go outside? Do you outsource or subcontract your design and layout work? Or maybe it's not applicable. Maybe you're not involved in the design or layout aspect. Or other, if it might apply to you. So if you could go ahead, just take a second to vote. Andy, we do have some good questions that have been posted here that I want to get to after the polling question is done. So if you can, if a couple more of you would vote, we'll get past that 80% threshold, so we'll see a good cross-section of our population that's dialed in today. Take a minute to vote. All right, thank you very much. That's great. I'm going to go ahead and close the poll now, and as promised, I'll share those results with you. So, Andy, nearly it's like 44% complete the design process in-house. Another 31% complete them when possible, and then next largest category is it's not applicable to them. So, Andy, a couple of questions that have been posted. Let me go ahead and bring those pull results down. The first question here, let's see. Can you make edits in the summary screen that you showed?
Okay, there's two different summary screens. One would be at the Pipe Wizard, where it basically just summarized what your selections were. In that one, you can't make them in that screen. You'd actually go back. There was a back button. Again, very similar to the way you'd install some sort of software where you can go next or back. Once you've designed your pipe network, if you're talking about that calculated results screen, and I can actually go back to it real quick. In this particular screen, the changes that you can make would be to edit the hole size, basically, is the major change that you can make there. Otherwise, you have to go back and delete a pipe, maybe change the length of a pipe, maybe add a branch instead of have one long pipe, maybe two shorter pipes to get the same coverage that you're looking for within the transport time and hole sensitivity. So that basically it's a report. It's slightly interactive in that you can make modifications on the screen. Again, the hole diameter is probably the biggest item that you need to adjust. It's not uncommon that you might need larger holes at the furthest points of your sampling lengths or branches so that they receive the same transport time and or sensitivity as the closer ones.
Okay, all right. Next question is, what happens when your room is not a rectangle?
Yep. And that's what I tried to simulate a little bit on that second design where we had the two sampling branches, two different lengths. It's very uncommon to have a layout that's exactly rectangular, if you will. Again, Pipe Wizard's great for those real simple rectangular spaces, but the manual pipe design is really what's required when you're going to go and do any kind of oblong shape. And again, even though I did a real simple scenario there with the manual layout, you can add additional branches, additional segments, especially if maybe there's one area of the room you want to have more detection or less detection. So the manual design is definitely the way to go when you have those unusual shapes.
Okay, all right. Last question for this section, then we'll get back to your presentation. Is there a way to set your end cap to a different height? Say you want to come down the wall 10 feet.
Yeah, sure. Again, when you do your manual design, much like I built it from the device up to a sampling point, there's no reason why you couldn't put an elbow in at the end and then bring another sampling point or termination point back down. A great example of that would be, think about a large atrium or some other large space with super high ceilings. Aspiration, much like a beam detector, are really well suited for these applications. And a lot of times people ask questions about, well, what about the height of a certain space, and what's the max height? Well, one of the great things about having an aspiration system is typically you're going to be bringing that pipe network up to the ceiling somewhere. Well, that piping has to come up from a lower level where maybe you mount your device. You can add additional sampling ports in those vertical runs up to the ceiling, which actually helps improve your protection against stratification and those type of things where you might get smoke at a lower level and it takes a little bit longer before it migrates its way up to the ceiling. So again, the manual design is really where you can do that type of customization of sampling points.
Okay. Andy, why don't we have a couple other questions, but why don't we get back to your presentation and we'll cover them at the next poll question.
Okay, great. So we've already gone through the pipe design. Again, quick summary, just to get your guys' feet wet with it and get a little more familiar with it. So now we're going to go ahead and move on to the configuration section. So again, from that standard selection window, we're going to go to View and then pull up the configuration. So once you select that, it will pull up your initial configuration screen. So what the configuration really does is there's three different tabs. It includes a general tab. This is where we're selecting pretty much more text kind of fields where we're selecting naming the device, putting the time and display in, and we'll go through each one of these individually. The second tab is for relays and thresholds. So this is where you're setting your alarm sensitivities, relay settings, whether you want them latching or non-latching, and really kind of setting up that whole action plan configuration system. Finally, the last tab is the network tab. And this is where you can set security passwords, integrate the device into your facility network. So through that TCP/IP Ethernet connection, you can place the device on that network, and then also establish the notification action plans, primarily through those email notifications that the system enables. So if we look at the first general screen, you might look at those general inputs and say, okay, facility name, facility location, that's no big deal. It's kind of like standard inputs. The one thing to caution you on and really implore you to do is to make sure those are as descriptive as possible for the actual location and the device as possible. Because these descriptive fields are the exact same fields that end up showing up in your email notifications. And if you have very watered down descriptions, it makes it difficult to go back and figure out what device is located. Conversely, if you're very, very descriptive in your fields that you fill into these locations, it makes it very, very easy to go back, and when you get that email notification, you know exactly which unit is in trouble or alarm and to address that situation. Also, if you look over on the left, when you open a file or create a new file, it does give you different folders for building, floor, and also the device. Much like any other folder, if you will, you can right-click those and rename those. So I would implore you to, once you set up your facilities in the General tab here in the configuration, is to go back and rename those levels on your windows or the folders to match, such that rather than saying FAAST Device 1, it would actually say ASD number 6 over on the left, so that you know exactly which unit to go and find and to go into to configure or monitor that device. Okay. The second field down and below is the date and time. The unit does have a real-time clock, such that if it's taken offline for any extended period of time, we're talking weeks, you would get a time fault if you don't download the corrected time. And then also the button lockout. There's a test, reset, and isolate button that will show in the monitoring section. You can lock out those buttons, again, providing a little more security, and it requires a password at the display panel in order for those functions to be enabled if they're checked as locked out. Okay, so here's an example of the email notification, and in the upper left you'll see that it exactly mimics what was put into that configuration field. And you can see that on the left sample, it gives you much more descriptive information than perhaps the right does. The right does give an actual address, but it's not necessarily as descriptive. So it's really, one of those fields where garbage in, garbage out, the more descriptive information you put in, the better information that people being notified via email are going to receive. So we go to the second tab within the configuration area. This is the relay and threshold tab. So with the highlighted red boxes here, this is where you can set both the alarm and the fault or trouble settings relays for latching or non-latching, whatever your configuration requires. And then also I highlighted the delay for the alarm thresholds. And again, even though the system does a great job of providing some great false alarm immunity, but if you add delays and it allows up to 60-second delay, it just gives that system a little bit longer to verify we really have a condition. We think about these systems, they're very early warning. They can provide detection of elements of combustion hours or even up to a day or so ahead of an actual combustion or a fire condition. So adding a 60-second delay to verify we really have a true condition it gives you that extra peace of mind and security that we're further reducing the potential for false alarms. Okay, so that's your alarm settings. Acclimate mode, if it's disabled, you basically have a night and a day setting. So here you can see each one of the alarm settings or the thresholds can be set with a day, night, or weekend sensitivity based on the clock that's set up with the night mode. So that would be a system that maybe is running not 24/7. It's running during the day. It's drastically different at night. You might want to have drastically different sensitivity readings from a day to night setting. But most of these systems nowadays are running obviously 24/7. We think about a mission critical kind of facility. And if you enable the Acclimate mode, what it allows you to do is put a min and a max sensitivity range into the system. And what the system does is it evaluates the environmental or background condition of what sensitivity it's seeing as background noise, and it'll basically drive the device to be as sensitive as possible without interrupting or getting into that background or nuisance-based noise when it comes to a sensitivity. So it drives the system down as sensitive as possible without necessarily getting into a range or sensitivity range which would generate false alarms. Finally, the network tab. The first box highlighted here, this blue box, it's where you're setting all your system passwords. So not only is there a web access password, there's also administrative password within the PipeIQ software. And then it's also where you can set up your server name and sending account for your email notifications. The second box, or the red box that I've highlighted here, this is where you can set up your IP address, again, through that Ethernet, putting the FAAST system directly on the network at the facility. Allows you to, again, get those email notifications, as well as ability through PipeIQ to remotely connect and monitor the device. Finally, the email notifications. You'll notice that you can set up to 6 different email notifications or individuals, and each one of those individuals you can customize what type of warnings or what type of alarms and or faults that they're going to be notified of. So you can see the first individual, myself, I might want to know about anything, whether it's a fault or an alarm. The next individual, maybe they're a facility manager, might only want to know about, or an HSE manager, might only want to know about any kind of alarms. The third individual, maybe a service and maintenance local personnel, might only want to know about minor and urgent type faults and alerts. And then finally, you might have someone like David George who's moderating today in marketing and communications, public relations. He might only be wanting to know when there's a Fire 2 condition because maybe you have to mitigate things from a public relations standpoint. So again, a lot of different ways to configure your action plan and to provide different notifications for different people within the facility or external to the facility. Okay? So once you're done with the configuration, you need to connect the device to the software. And how you do that is the red X at the FAAST device indicates that the device is not connected. It might be hardwire connected, but it's not software connected yet. So by right-clicking on the FAAST device, we'll open up this next dialog box, and you can scroll down and you can see the box or the selection for Connect Device. So if we go ahead and click Connect Device, the next screen will open, and you'll see that that red X changed to a green check mark. And that indicates that the PipeIQ software is now connected to the device. You get that green check mark. Then you can go to the Tools device. So basically all we've done is within the software we've created the configuration, but now we want to send that configuration from the software back down to the device so that both of them are synonymous and match up. So if we click on the Send Configuration button, that'll go ahead and send all of our settings back down into the device. So with that, we'll turn it back to David for the final poll question.
All right, Andy, thank you. The final poll question has to do with certified training. And would you or your staff be interested in attending a FAAST certified training course? It's something that we're currently contemplating, and we'd just like you to weigh in to say yes or no. This is of interest to me to be certified in this product, or it's not applicable, so please put no. So love for everyone to vote on this one because we're getting a measurement, and if you do vote yes, you probably will get an invite very shortly to a class that might be in your area on the FAAST product. So go ahead and vote. We'd love to get about 85%. We're at 80% right now, so if you can, go ahead and weigh in on this question. Would you be interested in a certified class? And Andy, we do have a number of questions here we'd like to answer following this. Great, thank you very much. We're at 85% that did weigh in on this. And Andy, overwhelmingly about 84% of the respondents indicated they'd like to attend a class in the future. Just so you know, we have, because you registered for this webinar, we will send you an invite should we have one coming to your area. So let me go ahead and bring that down. Andy, a couple of questions here. One I think I can answer. the PipeIQ is PipeIQ compatible with the Mac OS T, and it's not at this time, but it may be part of a future revision. And then the second one I think I can answer, Andy, as well, is one of the, we had an early adopter, I think somebody downloaded the early version of PipeIQ, and we're getting a fail to open connection with the specified database warning. And I know, Andy, that that's been addressed with subsequent revisions, so do go to systemsensor.com/FAAST and download a current version of that software, and that will take care of that issue that you might have had should you have downloaded it perhaps last fall sometime.
Yep. And since you posted that question, we'll also follow up. Someone will follow up individually with that individual to make sure that they get their connection.
You bet. You bet. So, Andy, the next question is, it deals with somewhat of the last question we had in the last session. If you forget end caps, will the software remind you?
Yeah, and it kind of snapped through the screen really quick when I showed that, but it most certainly will. When you go to calculated results, I'm not sure if you saw it, but a dialog box came up and said either there's an entity, meaning a pipe, that's not connected, or end caps missing. And so I went back in. I was able to double-click on each sampling branch, bring the description of that pipe layout up, and I was able to just simply click a selection box and add the end caps, and then proceed on. So it most definitely does. There are quite a bit of user interaction, check balance kind of things that'll protect the user from making a gross error.
Okay. Next question, Andy, is how important is it to enter altitude?
Okay. Yeah, the inputs on the configuration at this point, it's more of a reference point. It can come into play, and there is some aspects of that taken into the calculation. So obviously, if you're at significant elevations, talking Denver or something even higher than that, it obviously can play into the airflow calculations, just due mainly to the density change of the air. So, but aside from that, if you're in most other parts of the world or country, I should say, it's probably less required.
Okay. All right. So we have a couple other questions, but Andy, I know you have some presentation left. Why don't we get to that, and then we'll wrap with the remaining questions.
Okay. Great. Thanks, David. So now we've been through the pipe design. We've been through the configuration. Now we're going to go through the final element of PipeIQ, and that's the monitoring. And some of you that have been on the other webinars or seen other live presentations, we've done quite a bit of talking through monitoring. I'm going to go through that in just general as well. So we select the monitoring. It brings up the monitoring screen. And as you'll see, that monitoring screen does a great job of mimicking exactly what the device shows. So again, from a monitoring perspective in general, there's basically three main ways you can monitor a FAAST device. Obviously, the easiest is direct, right from the device itself. You're standing in front of the device, you can see what the status is and look at the user interface screen. The second is remote via the PipeIQ, which is this image that I'm showing here on the left is via PipeIQ. And then finally, you're also able to monitor through the Ethernet connection, and assuming that you have the system set up on an IP address, you can go in through any internet browser and monitor the device as well. So you're not necessarily tied into, hey, I don't have PipeIQ on my software, on my computer, I'm traveling around the world, all I have is my BlackBerry or my iPad. You still can go ahead and log on and monitor the device. So with the monitoring, no matter where you're at, the user interface is very similar, no matter which way you're looking at it. Basically identifies the 5 alarm levels, both all the way from alert to fire 2. 3 of those are highlighted here on this image. It also includes 10 levels of particulate indication. Those are the amber lights, shown 1 through 10 on the left. And then it also has fault indicators, and those are basically across the pendulum, across the bottom of the image. And those indicators are anything from configuration, the sensor to time I talked about. If you didn't set the time and the device was configured, took offline for a long period of time and brought back out, you'd get a time fault because the clock in the device doesn't match the clock in the software. Aspirator, so that's your fan, making sure the fan's operating. It also offers dual flow monitoring, so you can see that it has a high and low airflow at the ends of that pendulum, which can be faults. And not only does the FAAST device monitor the pipe network for airflow, but it also verifies that the airflow is getting across the filter and across the chamber. Because at System Center we really decided it's great that the airflow is getting to the device, but it's even as critical that the airflow is actually getting into the chamber. So we check for both of those. And then as I started to talk about in some of those configuration screens, there's multi-level password protection that you can lock out the test reset button shown on the screen here. You can also lock out other features. So monitoring, the image here on the left is actually a photograph of the actual display. And the image on the right is through the PipeIQ monitoring software. So you can see very much mimic each other. There's not a lot of training to be done between looking at, no matter if you're looking at the device or looking at through the software. Basically, great mimics both very, very well. So again, as we talk about, it mirrors the extensive device display through PipeIQ. The image here is the PipeIQ image. There's also the functional on-screen test, reset, and isolate buttons. And just like you would if you were standing in front of the device and pushing the buttons, if you're on screen, all you have to literally do is click on those buttons, and it'll put the unit into test, reset, or isolate through the PipeIQ software. Again, as long as you've selected the administrator setting within PipeIQ, there's also a read-only version of that as well. There's also an event log that tracks up to 18,000 events, and we'll show that a little later, including alarms, faults, or other user interactions. And then finally, there's a selection tab that says View Trend Graph, and that allows you to provide analyzing tools to analyze alarms or troubles that might occur within this device or the system. So on this next slide, you can see the top of the image is basically the actual mimic view of the monitoring. But if you select Trend Graph, what it'll actually do is it'll bring up a trend graph and it'll monitor it. The horizontal lines, such as the blue, the orange, the yellow, the red lines, those are basically your different alarm levels or alarm thresholds. So here we did a test. You can see the unit went into full alarm. You can also see from the purple and the light purple lines that not only do we exceed each the lower levels of alarm, but we also exceeded the Fire 1 and Fire 2 conditions, the yellow and the orange lines. And again, from a historical perspective, you can go back into the device and see, okay, we went into a false alarm back on Friday at 5 o'clock. What exactly happened? What did the device see, and those type of things. So it allows you to do some trend graphing and to identify maybe if there's some configuration changes that need to be done with the device. Okay? As I mentioned, there's several different ways to monitor. Again, it'll keep track of live events. So now we've gone ahead and went from the mimic view to the log view, and that brings up 3 new tabs. So here you can see a live view of a variety of events that have occurred, or stored events. And again, remember, it keeps up to 18,000 events. And then also any user interface messages that you might want to import. So it's real simple, just like sending an email. You can click Add Message. It gives up a bar, very similar to Outlook. Type in your message, click Send, and it basically puts that stored message into the memory as well. This example here is just showing the change filter. It was done last Friday at 5:30. Okay? So again, a lot of different ways to monitor beyond just the device monitoring. You actually can do some strategic planning and other types of interactions as well. And then finally, the final way to monitor is through the Internet browser. So again, the onboard Ethernet provides local connectability and allows you to monitor any FAAST device from anywhere around the world via the Internet. It's really simple. Assuming that you've set up the unit on the network, all you have to do is go in, type in the IP address into your browser screen. Ideal for obtaining live status from an iPad or smartphone. So you run the scenario, you're responsible for some facilities, you're halfway around the world, you get an email that says the unit went into some sort of fault. You want to go ahead and dig into the product, figure out what's going on. Before you bring out, you start up your laptop, maybe you have a smartphone or an iPad of some kind on you. You can go ahead and punch up the unit, get a live view of exactly what's going on, live, real-time view of what's going on with the device. Maybe it's a situation where you realize that there's some configuration changes that you need to make. Then you would have to go back into the PipeIQ software through a laptop or other in order to make those changes. So again, really nice ways of monitoring the device, both at the device, remotely via the PipeIQ, and then if you utilize the Ethernet connectivity through an IP address in any internet browser. So with that, we really kind of completed the discussion on PipeIQ. I do want to mention that there's additional FAAST resources out there on our System Sensor FAAST landing page, including the PipeIQ download. I'd also mention again the last item on this list of collateral is the archived webinars, which if you weren't able to join us for any of the general FAAST overviews, I'd really recommend you do so to get up to speed on the product and recognizing the differentiators and advantages of FAAST. We also have some additional educational opportunities. On the System Sensor website /training, you can access seminars, so you can get a schedule of what kind of A&E seminars we're putting on that we always do each year, as well as any of those archived webinars. We're also working on online FAAST training. This will be similar to the other online training that we have. Somewhere in the order of 20 to 30 minutes, you could go through and get yourself up to speed on the product. And then also any future FAAST webinars would be listed here as well. And to David's point on that last poll question, we're also putting together a certified training course. We recognize, and your poll responses really indicated that you're looking for additional training to get up to speed and understand the product and the interaction with the product even more. So we're putting that together, and we'll have several of those around the country to make them as convenient as possible for each of you. So with that, I'd like to thank you for joining us. David will handle a few more questions here. I would also like to recognize that Con Flowers is our sales lead for the aspiration product, as well as Luis Barrows, who is our system sales engineer. If you have questions on pipe layouts, setting up systems, need help laying out that first system before you can quote it, Luis is a great resource to reach out to, and he may actually be on the call here as we close out with final questions. So with that, David, I'll turn it back over to you.
Yep, very good. And Luis will be joining us here. He's going to unmute his phone and tackle any of these questions that are most applicable to him. So you see the contact data there. Feel free to contact any of those gentlemen on anything related to FAAST. Andy, the first question is basically the conventional and intelligent question or addressable question that we get. Is the FAAST only integrated via relays to the fire panels, or is there a smart interface via an RS-485 or addressable SLC coming?
Yep. Today, the product, the FAAST product, is a conventional device. So to tie back to any fire panel would need to be done through a monitor module or a multi-monitor module, depending on the brand. We are in development on a SLC-based product that would be, allow it to operate like any other intelligent product, stand right on the SLC loop. That's in development. Timing will follow as far as when the availability will come on that. But I'd implore you to, get your feet wet with the conventional product, even if you know that down the line you'd want to use an intelligent. 99% of all the interaction with the device will be very similar. It would just be how you'd wire and connect to it. It would be the only differences.
Okay. Maybe we'll toss this one. Luis, are you there?
Yes, I am. Can you hear me?
Oh, excellent. Why don't we toss this one to you? Are there any downloadable examples of layouts, including ceiling, subfloor, HVAC return air available?
Yeah, we currently do not have anything, examples laid out. If anybody has or looking for any particular, I have been helping design systems, so I can provide some examples. But we do have we do have examples in our manuals, as far as illustrations, but not downloaded.
Okay, very good. Maybe something that we should work on. So the next question: can dynamic IP configuration be used if remote access is needed?
Was that for me? Yeah, you could set both. You could set it both for static and dynamic IP address. Although making it dynamic would probably be a lot harder, because if it's constantly changing to get an IP address, static is where you actually force it, to sit on an IP address. But yes, either way you can do both.
Yep, and if I can add also, if you talk to most IT personnel within facilities and their hanging device, they would much prefer it to be a static address that they know it's taken, it's assigned, and it's recorded that way, such that it's not dynamic, constantly moving, and they don't know where these emails are coming from and those kind of things. So I know in our own IT department, they mandated that it had to be a static address if it was going to be within our facility. So.
Okay. All right. A couple of questions related to CAD. Can the wizard export to CAD at this point, or what's our plans for that?
You want to take that one?
Yeah, I'll take it. Yeah, not currently at this time. It cannot be exported. As Andy mentioned, the only interface with CAD would be the DXFs importing them, so you can work on them to help you lay out the system. But then, as a result, basically the output of the PipeIQ software is just the PDF files, which are the bill of material and the pipe layout files. At this time, I mean, we will, if we need to, if that's definitely, we will reevaluate that.
Okay. All right. Andy, maybe this is one for you. The user or the attendee here is really questioning what the emails are for. Why do we have an email notification piece to this software?
Well, again, even though not every aspiration product is put into mission-critical type facilities, but rather than having to have the device be monitored 24/7, or think about an application where maybe it might not be tied back to a fire alarm panel for whatever reason, rather than having to have that device be monitored 24/7 or someone checking it hourly or something along those lines, the email notification allows you to notify those up to 6 email addresses of any kind of fault, any kind of alarm. So again, you think about a facility manager. It's 3 o'clock on a Friday to Saturday morning, and he gets an email notification that it says filter change, dirty filter needs to be changed kind of thing, flow fault due to filter. You have up to 72 hours in that case, if it's a minor fault, to go ahead and wait prior to making that change. After 72 hours, you'd get a major fault. So by having that kind of email notification, it just allows people, A, the quickest response time, and then B, it allows them to identify what kind of action plans they want to put into place.
Okay. And it's probably important to note that they can have it as an option not to use email notification.
Without a doubt, right.
Okay, all right. We are at the top of the hour. We do plan to answer a couple more questions here. So if you can stay with us, please do. We do appreciate you being here. A couple questions on the factory certified training. Do we require that today? I think we answered that, but why don't we go ahead and just verbalize that one more time?
Yeah, it's really not, at this point, we don't require it. We are doing a lot of these webinars to at least get people's feet wet, to allow them to at least some insight into be able to ask, some more intelligent questions and get up to speed a little quicker. In addition to that, we are planning to do some sort of certified course. It's not, we don't view it as needed to be required. However, we recognize that a lot of ESDs and other designers, they want to be certified so that they feel comfortable and that they can have peace of mind that their people designing systems have been trained accordingly, and we recognize that. So that's why we're work towards that end game.
Okay, all right. Next question, is this product available outside of the USA today, specifically Canada?
The Canadian version of this product with ULC listing is expected to be released within the next 2 weeks. We do have all of our required agencies. We're just buttoning up some things to launch it into Canada. So again, in the next 2 to 3 weeks, you should be able to access it in Canada, yes.
Okay. Maybe kick this one over to Luis. What is the minor relay? Andy mentioned that in the webinar.
The minor fault. There are multiple troubles that the detector can put out, and they've been labeled as minor and major. So in an example, a minor fault will be if there's been a change to the airflow from originally set up. If there's a 20% change of the airflow, you'll get a minor fault. If this is neglected, the minor fault will change to a major fault in the case of the airflow. If there's a change 50% or greater to the airflow, then you would get a major fault. Another example is if they're initially, like Andy mentioned, on Friday evening, you get an email that says it's a minor fault because the filter is clogged or needs to be replaced. That will be a 72-hour minor fault, which will then turn to a major fault at the end of the 72 hours. So just, you know, so there's 2 levels of faults.
Okay. All right. That does conclude the questions that we have. On behalf of System Sensor, I'd like to thank you for joining us today. As a follow-up, we will be sending you a brief survey in about an hour and would appreciate your help in filling that out. And we do plan to reward one of you that completes the survey with a $50 Target gift card. Thank you for joining us today. This does conclude our webinar. Have a nice rest of the day.